Hello, my name is Austin Crowther, and today I will be myth-busting Star Trek's black holes. First off, what is a black hole? Well, according to NASA, a black hole is defined as a place in space where gravity pulls so much that even light cannot get out. Mathematically speaking, if compressed small enough, anything could become a black hole. See, everything in the universe has what is known as a Schwarzschild radius, a tiny amount of space that were you to collapse the entire mass of an object into, its density and gravitational pull would be so great that not even light could escape from it. Here are some simple facts about black holes that most people misunderstand. Black holes cannot be seen directly. In movies, black holes are depicted as giant swirling masses. In actuality, scientists aren't able to observe black holes directly, not even with X-ray or electromagnetic radiation. Scientists know black holes are there because of the way they interact with the matter around them. Black holes are not empty. Unlike their name, black holes are anything but holes. Black holes are some of the densest objects in the universe. It is the great density of a black hole rather than its fictitious emptiness that sucks things in. Just as Earth has a gravitational pull on the moon because of its larger mass, a black hole has a similar pull on the things around it. Black holes are not wormholes. Unlike the science fiction popularized by the Star Trek series, black holes are not wormholes. Wormholes are said to be tunnels that connect distant parts of the universe. But if an object is sucked into a black hole by its extreme gravitational force, it will not appear somewhere else in the universe. There is no evidence that wormholes exist at all, even independently of black holes, though Einstein's general relativity field equations predict their existence. Black holes won't suck in the universe. Black holes only absorb objects close to them. If the sun were a black hole, the Earth, 93 million miles away, wouldn't change or be sucked in. Only objects less than 2 miles away from the sun would be in danger if it suddenly became a black hole. Not every star can become a black hole. Black holes form when huge stars die and leave behind a superdense core. When our sun eventually fizzles out, however, it won't become a black hole because it is neither big enough nor dense enough. The smallest black hole that has been discovered is thought to be 3 times the size of the sun. There are only a few known black holes that small in existence. Most are at least 10 times the size of the sun, and some can be millions or billions of times bigger. Let's observe these facts by looking at a scene from the 2009 Star Trek reboot. In the scene, the Romulans drop a red matter bomb into a hole made by a drill. It triggers the formation of a black hole which collapses the planet and wipes out the Vulcans. But here's the real science behind it. Red matter? Okay, I'll give them that. But still, to make a black hole it takes mass, a lot of it, or a little bit squeezed into a very tiny volume. If the mass came from the planet itself, there's a problem. As the mass compresses and falls into the black hole, it gets hot. Really hot. Millions of degrees hot, and emits X-rays and other types of radiation, and would probably pile up outside the event horizon, or the point of no return, and prevent more matter from falling in. This is what happens when a black hole orbits a star. We can detect those systems due to their incredibly strong emissions of X-rays. Assuming they could overcome that problem, it would still only create a teeny tiny black hole. If you turn the entire Earth into a black hole, it would only be about a centimeter across, the size of a marble. Initially, the red matter black hole would be incredibly small, probably smaller than an atom, and that would make it hard to gobble down enough mass to grow rapidly. And assuming they could overcome that, and assuming this magic red stuff actually exists, well then yeah, they could create a black hole, but it doesn't, and they couldn't. Incidentally, the gravitational force you feel from an object depends on 2 things, the mass of the object and how far away you are. So weirdly, once Vulcan collapsed into a black hole, the gravity felt by the orbiting ships didn't change. A lot of people think that black holes have infinitely strong gravity, or they can reach across space and grab stuff, but really they're just gravity. As long as you're far enough away, you're okay. Crazy, right?